Alright guys, if you're going into AP Calculus AB, this video will be a great introduction to the course. It can also help recap past knowledge for people who have already taken this class. Let's go! One of the three main topics of calculus is the limit. The limit is the y value a function approaches around a specific x value. We can evaluate limits by basic substitution, factoring, and also by looking at the graph of the function. By looking at the graph, we can see what y value the graph approaches as we near a certain x value. Left and right hand limits are limits evaluated or approaching from the left or right side of the graph. An overall limit only exists when the left and right hand limits are equal. A function is continuous at a point if the function output is defined and equal to the overall limit that exists at that point. There are three main types of discontinuity. As you can see from the examples, they each have a point where one of the conditions for continuity is not met. The average rate of change is found by taking the change in y over the change in x on an interval, and it tells us the average slope over that interval. But what if we want to find that rate of change at one point? The derivative at a point is synonymous with the slope at a point, or the instantaneous rate of change. You often see it represented like this, where if you derive a function f of x, the derivative function is f prime of x. You can differentiate a derivative to get a second derivative, and so on. You will also see a derivative represented like this, dy over dx. The limit definition of the derivative will give you the derivative function of whatever function you used as f. You might be wondering, how do you derive a function? Well, there are a set of rules you can use to differentiate. The derivative of a constant term is always 0. The derivative of a constant multiplied by a function is just a constant multiplied by the derivative of the function. For derivatives, addition and subtraction are similar, as you can separate the terms and differentiate them independently, remembering the addition and subtraction signs between the differentiated terms. For functions being multiplied or divided, there are the product and quotient rules when deriving. The chain rule applies to composite functions, complex functions created by two or more functions. Alright guys, so here are the most common derivatives you'll need to know in AP Calculus AB. I'm missing a few, including the derivative of the inverse and the derivative of the integral, so if you're curious about any of those, you can search them up. Derivatives have many applications, including particle motion. Acceleration is the derivative of velocity, which is the derivative of displacement. Related rates problems, linear approximation and tangent lines, optimization, and implicit relations are all applications of differentiation. L'Hopital's rule is another example of a way we can use derivatives, as it helps us solve limits of indeterminate forms. The last major topic of calculus is the integral. The integral is the area between a curve and the x-axis, commonly referred to as the area under the curve. Area under the curve can also be evaluated using rectangles, for example Riemann sums, or trapezoids, for example the trapezoidal rule. Integrals and derivatives are inverse operations, just like addition and subtraction, and multiplication and division. This is how an integral looks. It has an integral operator, an integrand, and a differential. There are two types of integrals, definite and indefinite. Indefinite integrals have no bounds and are just antiderivatives. When you evaluate them, they give you the expression that derives into it. Definite integrals have limits of integration and output a specific area. There are rules for integration, but basically you just do the inverse of derivation. Once you evaluate an indefinite integral, if you derive your answer, you should receive the integrand that was in the integral. For definite integrals, we can apply the fundamental theorem of calculus to evaluate. The fundamental theorem of calculus allows us to take the antiderivative function of the integrand and substitute the upper and lower bounds into the function to evaluate a definite integral. Integrals, like derivatives, also have many applications. The average value of a function can be determined using definite integrals. Particle motion, accumulation of change, area between curves, and volumes all involve integration. Differential equations can also involve both derivatives and integrals. The two most popular theorems in AP Calculus AB are the mean value theorem and the intermediate value theorem. The mean value theorem states that if a function is continuous over a closed interval and differentiable, not required at the endpoints, there exists a point along the x-axis inside the interval at which the tangent line to the graph at that point is parallel to the secant line through the entire interval. The intermediate value theorem is more straightforward, stating that if a function is continuous over a closed interval, it must pass through every y value in between the y values at the start and end points of the interval. And that's all. I didn't go extremely in-depth into some of the more advanced concepts, so if you'd like future videos on some of the more niche topics, let me know.